Welcome back to Chapter 5. In Chapter 5, we're going to continue with some calculations. And first, in this Part 3, we're going to do specific heat and heat capacity. And then we're going to move on and do some calculations involving calorimeters. So there are two types of heat that we measure. Specific heat, okay? Specific heat, and this author uses a small s, is the amount of heat required to raise the temperature of 1 gram of water 1 degree C. Heat capacity is the amount of heat required to raise the temperature of an object by 1 degree C, okay? So note the difference here because they're going to have different units. So we can use the specific heat of water, and specific means that is specific to water. Only water has this specific heat. It is 4.184 joules per gram times degree C. And so we can use the specific heat of water to determine the heat capacity of water. So in the case of the heat capacity, the specific heat, it's joules over gram degree C. And in heat capacity, it's going to be joules per degree C. So make sure that you understand that that's going to have different different units, okay? So if a substance has a specific heat, and you don't memorize specific heats, they're in tables. A lot of them use lowercase c, and that's what I'm used to, so catch me if I do it, sorry. The specific heat capacity is times mass times the change in temperature. Then you can calculate the heat capacity. This is the energy, this is the specific heat, this is the mass, this is the change in temperature, okay? And then once you get that, then you can calculate the heat capacity times delta T. Okay, so there's two separate formulas, and you may see this as like that, or like that, and then Q is, notice that this one you're not going to be worried about the mass. All right, so these are just some specific heat values that you might find in a typical table, okay? And they're in joules per degree times degree C. I'm sorry, joules per gram times degree C. So calculate the amount of heat in kilojoules required to heat 255 grams of water from 25.2 to 90.5. So when we use the formula to do these calculations, all right, we're going to be using Q equals the mass times C, okay, times delta T. And remember, the C is going to be your specific heat. All right. So when we're talking about water, water's one I always remember because it's how many calories are in a joule. The 4.184, it's the same number. So that one I can always remember, but you still can look it up because it's given to you. All right. Calculate the amount of heat in kilojoules. Okay, so heat is the Q, right? M is mass, C is the specific heat, and the delta T is the final minus the initial, okay? So it's always a good idea when you're working a problem to take inventory of what you have. And you want to make, because you want to look at that, because anytime you have a constant like C, you want to make sure that everything's going to be in those same units. So in this problem, I have a mass of water is 255 grams. I know what the C of water is. The specific heat of water is 4.184 joules over gram times degree C. And to get the delta T, and notice I've got grams, I've got grams. If I use this, I'll have joules, and then the degree C, so I keep my temperature in degrees C. So that is going to be the final 90.5 degrees C minus the initial, which is 25.2, because it goes from 25.2 to 90.5. So that's how I know 90.5 is my final. And so delta T is always T sub F minus T sub I. That's where that comes from. And so in this case, I'm going to go ahead and figure out that that's 65.3 degrees C. So I have the mass, I have the specific heat, which is C, I have the delta T, and then I will be able to calculate that in Q. In joules. Okay, and then if I want to go take it to kilojoules, remember, whatever it's asking for, that's what you're supposed to give it to it. I'm going to have to do that final conversion to kilos. Okay, all right, so the amount of heat, which is Q, is going to be equal to the mass in grams, so 255 grams, times the specific heat of water, which is 4.184 joules, divided by grams times degrees C, times delta T, which I already did that conversion, which is 65.3 degrees C. Okay, that's going to get rid of grams. That's going to get rid of degrees C. That's going to leave me with joules. And so I can go ahead now, since I know it's supposed to be in kilojoules, and take my joules on the bottom. So there's 1,000 joules in 1 kilojoule. And I set that up, and now I'm going to do the math. And so it's basically 255 times 4.184 times 65.3 times 1, then divided by 1,000. All right, and if you do that math the same way I do, you're going to get 69.7 kilojoules. So this part is really important because you want to make sure that you're looking at what your units are going to be, and you always want to look at your constant to make sure that you're going to have the right units to get rid of those or cancel out the units in the constant. And then here is your practice problem for this. Now, in this particular one, you're going to have to rearrange some things, and so this one is a little more challenging than the example that we worked. Okay, but there are, in extra practice, there are some that are simple, like the one in the sample one. All right, that's it for specific heat and heat capacity, and we're going to use heat capacity in the next section where we look at constant pressure calorimetry. That is, some people call it the styrofoam cup calorimeter.